Good morning, one and all. I welcome you all to this national webinar on mathematical applications in medical diagnosis organized by Department of Mathematics, Andhra Laila College in collaboration with IMRF Institute of Higher Education and Research, India. I congratulate the Department of Mathematics, teachers and the students under the headship of Sri P. Venugopal Rao Garu for picking up an interesting topic and also opening the horizons of mathematical applications that today students, research scholars and other faculty may work in medical sciences also with mathematical knowledge. I thank Andhra Laila College for collaborating with IMRF and also encouraging such interesting webinars during this season. I thank the management, especially Reverend Father Rector Balashori Garu, Reverend Father Correspondent Sahaya Raj Garu, Reverend Father Principal Victor Manuel Garu for always looking high, thinking of the student community and the faculty to promote research-oriented education. I thank you all, fathers, for collaborating with IMRF, and I deem it as a pleasure to work with Andhra Laila College in collaboration. Once again, I thank all the hands behind this national webinar to happen today, and especially invite our resource person Dr. Felix Garu from VIT Chennai. I thank the IMRF team for airing this national webinar on the Red Talks platform. I, in the capacity of the collaborator, I announce the opening of this national webinar. We request Reverend Father P. Balashari, Rector, Andrella College, to bless this national webinar.
Respected Dr. Felix Garu from the Department of Mathematics, VIT Chennai, the resource person for today's webinar. Reverend Father Dr. Sagai Raj, our correspondent. Reverend Father Victor Emmanuel, the principal. Respected Sri Venugopal Garu, Head of the Department of Mathematics and the convener of this webinar. Respected Dr. D.B. Ratnakumar Garu, Founder, CEO, IMRF. Reverend Father G. Kiran Kumar, Superior of Jesuit Scholastics and the coordinator of this webinar. The co-conveners, beloved members of the department and all the participants. A very good morning to all of you and God's special blessings to you all. I am glad and privileged to bless and wish all of you for the success of this webinar. The topic chosen for the webinar, Applications of Mathematics in Medical Diagnosis, is an apt and relevant topic to the present COVID pandemic situation. Surely the talk will enlighten our minds to understand the interconnectedness of mathematics and medical sciences. I thank Dr. Felix for availing himself to be the resource person for this webinar. I am sure, sir, your talk will make great intellectual impact on the minds of all the participants. I am grateful to Dr. Ratnakar Garu, who is ever ready to do anything for our college. I remember last year, many departments of our college have organized national and international seminars in collaboration with you, sir. That is the love and gratitude you express towards your alma mater. Thank you very much for your collaboration. I pray for God's blessings on you and wish you all the best to organize many more seminars in order to help the staff and students to row deeper into the vast sea of knowledge in every field. Thank our Department of Mathematics, headed by Sri Venugopal Garu, for all the painstaking efforts you have taken to organize this webinar amidst various difficulties and inconveniences. I thank and wish all the participants a very enriching experience from this webinar. God bless you all. Stay at home, keep safe, keep healthy. Thank you.
Thank you, Father. Now I request Reverend Father G.M. Victor Emmanuel, Principal, Andrella College, to greet the audience.
Good morning, everyone. I warmly welcome to this webinar being conducted by Mathematics Department. As you know, this COVID situation makes most of us to make use of the time in a proper way and a useful way, so that we come out of this COVID pandemic in new solutions. And our Loyola College is taking initiative. Every department is taking initiative to improve our knowledge, to improve our capacity to withstand this COVID pandemic. Also, how to impart knowledge, how to get knowledge. Modern techniques have come into our focus. So this webinar being conducted by Mathematics Department, which I also belong. I'm very proud of it. Also proud of our college. A few things about our college. As you know, we stand first among the autonomous colleges, both the Telugu states put together, both Telugu, Telangana, Andhra put together, we stand first, and 36th rank, NIRF ranking, so which we consider last time we had 45th rank, this time we have 36th rank. So through various people we are able to achieve this, so we must stand up to this particular ranking. So we have a lot of facilities, lot of departments, big area, lot of greenery, and many new courses being started, and mathematics is one of the growing mathematics department where it is involved in every new course that we start. So the staff are also challenged to get into the new way of teaching, new courses, new subjects. So I appreciate the department and other members, HODs, and other people who are helping the whole program to be in a successful manner. I also welcome the speakers who are coming and other college members, students who are participating in this. A very fruitful stay with us and gain something, and be safe, stay at home, make use of your time, and be careful that you don't spread this COVID, but spread knowledge and wisdom. Thank you.
Thank you, Father. Now I request Shri P. Venugopal Rao Garu, Head of the Department of Mathematics, to brief the national webinar.
To all of you, on behalf of Department of Mathematics, Andhra Loyola College, I extend a warm welcome to each and every one of you to the national webinar on applications of mathematics in medical diagnosis. Department of Mathematics has been one of the major departments right from the inception of the college in 1954. The department has been striving its best for academic and personal excellence of students. The department lays special emphasis on the development of intellectual ability along with analytical skills. The department is proactive in its attempt to update curriculum to help students remain competitive in a globalized society. The department has grown from its humble beginnings and now has 25 faculty members. The department offers 9 undergraduate courses along with 1 postgraduate program, MSc Mathematics. Department also offers general electives like quantitative aptitude, analytical aptitude to provide job opportunities to students of all combinations. The department is engaged in student-centered activities like skill development workshops, seminars, and guest lectures. Staff members of the department publish research papers in various international research journals. Today's webinar aims at providing a platform to share information and ideas on applications of mathematics in medical diagnosis. I thank Dr. Dr.Ratnakar, founder and CEO, IMRF Institute of Higher Education and Research India, for collaborating this webinar. Not only this webinar, whatever may be the seminar or conference proposed by our department, Dr. Ratnakar is always ready to support us. I am happy to inform you that Dr. Ratnakar is an old student of our department. He conducted nearly 200 international conferences in all over India and in some foreign countries also. He is the editor-in-chief of 8 international research journals. We are really proud of you, Dr. Ratnakar, and thank you very much for all your support. Once again, I extend a warm welcome to each and every one of you, and a special welcome to Dr. Felix from Department of Mathematics, Vellore Institute of Technology, Chennai, who is the resource person for today's webinar. Thank you, one and all.
Thank you, sir. Now we request Reverend Father G. Kiran Kumar, Department of Mathematics, to kindly introduce today's resource person, Dr. A. Felix.
Respected Father Rector, Reverend Father Principal, Father Vice Principal, Dr. Venugopalagaru, the Head of the Department of Mathematics, dear staff, students, and the participants of this webinar, good morning to you all. I am privileged and honored to introduce to you the resource person of today's webinar, Dr. Felix A. Dr. Felix is working as the Assistant Professor of Mathematics at the Vellore Institute of Technology, Chennai campus, Tamil Nadu, India. He obtained his doctoral degree from the University of Madras in 2015. His research focuses on fuzzy sets and systems and fuzzy graph theory. He was the recipient of the Maulana Abdul Kalam Azad National Fellowship Award by the UGC for doing his PhD and for the Raisin Research Award for publishing the highest number of papers in the year 2012 and 13 by the Department of Mathematics, Loyola College, Chennai. Moreover, he was recognized as a young researcher for the fuzzy systems by the Integrated Intelligent Research, IIR, Chennai, for the year 2017. He published more than 45 articles in the reputed journals and delivered 15 invited talks in the conferences and workshops, etc. At present, he is guiding 4 doctoral students in the field of soft computing. On the personal note, I know Dr. Felix since 2008. He is a hardworking and studious person, a man full of energy to achieve his goal. He is committed to his task and he gives his best to it. When I approached him to address our students through a webinar, he joyfully accepted my invitation. We thank Dr. Felix for accepting our invitation. And now, may I invite Dr. Felix on behalf of the Department of Mathematics, Andhra Loyola College, Vijayawada, to this webinar. Wishing you the very best to inspire our students and staff in the field of mathematical research. I invite you, Dr. Felix, to this webinar. Thank you.
Thank you, Father. Now we request our resource person, Dr. A. Felix, Assistant Professor, Department of Mathematics, Vellore Institute of Technology, Chennai, to speak to our audience. Welcome, sir.
It's a very good morning. First of all, let me thank the management of Andhra Loyola College, Vijayawada, Reverend Father Rector, Reverend Father Correspondent, Reverend Father Principal, Reverend Father Vice Principal, and the head of the Department of Mathematics, Professor P. Venugopal Rao, the convener of this webinar, and then Dr. Dr.Ratnakar, founder and CEO, IMR of Institute of Higher Education and Research, and the co-convener of this webinar, and the coordinator of this webinar, Reverend Father Gopakaran Kumar, for providing this wonderful opportunity to meet you all through this webinar. Okay. So today my talk is on fuzzy inference system for medical diagnosis. So I would like to give this apple to all of you to taste it. You may taste. Okay. The outline of my presentation is introduction to fuzzy sets, extension of fuzzy sets, membership function of fuzzy sets, fuzzy number and arithmetic operations, fuzzy inference system, Mamdani and Sojourner method, applications to type 2 diabetes mellitus diagnosis, and the current trends in the fuzzy sets and systems. So we know the logic. Logic is the declarative sentence that gives the value either true or false, but not both. Okay, so that's just what we have learned in the discrete maths about logic. For instance, today is the Saturday. This is the declarative sentence. What is the truthness of the statement? The truthness of the statement, either true or false. Since today is Wednesday. The truthness of the statement, false. Today is not Saturday. Let me give another example. Today is a beautiful day. So it may vary to person with a certain degree. So for me, this is a beautiful day because I'm meeting all of you through this webinar. For others, maybe I feel this is extremely happy a day, extremely beautiful day. For others, it may be bad or very bad or good, extremely good. It varies person to person with a certain degree. Okay. So I will give another example. A liar says, I'm a liar. So whether this person speaks truth or not. If you say yes, he speaks truth, but he is called liar. Okay. How he speaks truth? The second one, if you say this, he speaks false, then he himself accepts that he is a liar. So you cannot say no. So you cannot assign two value through our logic. Similarly to the first statement, today is a beautiful day, where you cannot bring two values. So this statement also, liar says I'm a liar, where you cannot bring two values. Something we need to bring in between true and false. Okay. That's the reason the fuzzy logic is brought into the picture. So I've given an apple to all of you to taste. Is it tasty? Is the apple tasty? If your answer in the form of yes or no, that is a Boolean logic. So you cannot express your tasty with the Boolean logic, yes or no. Somebody feel that it's very much tasty, it's medium level tasty. Somebody would say this very less tasty, no tasty. Okay. So this kind of term, very much, little, medium, very no, less, and then no tasty, these kind of value cannot be dealt by our Boolean logic. So this can be dealt by our fuzzy logic. Okay. So this fuzzy logic provides the human way of thinking. Whatever we human think, that can be brought into the picturized form through our the fuzzy logic. Our classical set is applicable only when the event is deterministic, the information is clear and unambiguous. So when the situation is undeterministic, when the information is not clear, so we cannot deal our classical set. So therefore, fuzzy sets as brought into the picture. Actually, these fuzzy sets were introduced by Lotfi Alizadeh in the year 1965. But before him, so many great philosophers and mathematicians who were working on fuzzy sets, and they touched upon fuzzy sets. Russell, who is the English philosopher, in 1922, who claimed that all language is vague, and also he went further saying that vagueness is a matter of degree. So from him, in 1937, Bloch outlined the concepts of fuzzy sets, but he was opposed by the many United States people. He stopped on working on fuzzy sets. And later, in the year 1965, Lotfi Alizadeh has given a life to these fuzzy sets. So the fuzzy set defined like this. Fuzzy set is the ordered pair. Okay, this is the ordered pair. So X is the element of your A. A is the fuzzy set in which every element of X will be assigned the membership grade. So mu of A of X is the membership grade of our element of A. So this membership grade takes a value between 0 and 1. Okay. The membership value will take between 0 and 1. So usually the fuzzy sets is represented in this form, either this form or mu of x by x. This is not the ordinary way of division. It's one of the representation for discrete case. For the continuous case, somebody using some of them are using the integrations. Okay, that is also one of another symbol of representing fuzzy sets. Okay, so this is the form that we are seeing. Okay, so you can ask me, see in fuzzy sets we takes the value between 0 and 1. In probability theory also, we provide the value between 0 and 1. Why do we the need of bringing fuzzy sets here? You can ask me. Yes, of course. Those days, probability theory were used to solve the uncertainty. Okay. But it cannot quench all sort of uncertainty. Okay. So let me give a situation. Under what situation our probability theory differ from the fuzzy sets? I'll give during this COVID situation, we are advised to increase our immunity power. Doctor would always say whenever we are sick, doctor would advise us to take a lot of fruits, especially apples. Okay. So here my intention is also to have a apple. Okay. My intention is to have a apple. So what I'm doing, I'm sending my brother to buy a apple in the market. So to buy a apple with the tasty and red color. Okay. So I need a apple with the red color and tasty. So here I have two kind of uncertainty. The first one, what is the guarantee that my brother will get the apple in the market? What is the guarantee that the apple is available in the market? Okay. The availability of the apple can be determined by the season, depends upon the season. So during what the season we can get the apple. During the winter we will get the lot of apples. Okay. So the season will determine whether the apple is available in the market. So that one uncertainty. The second one, what is the guarantee that the apple is tasty and the apple is red color? So the tasty vary to person. Okay. So I may feel the apple is very tasty, and if I take the same apple from other side, other people, the people who are living in Kashmir, Shimla, they might have tasted the apple is so tasty. So when they taste, they may feel this is not so tasty. Okay, it varies to person in a certain grade. The first one, the availability of apple in the market, this uncertainty can be dealt by our probability theory. Only two choices are there. Either you will get or not. Either you will get the apple or not. Only two possibilities. Only two choices. Okay. So this is two valued. Okay. So that value of whether he can get the apple in the market can be determined through the probability theory. Okay. Of course, the season will determine. And second uncertainty is, what is it? The tasty and red color apple. The color also purely red and moderate red, no red. These are the possibilities there. So this uncertainty can be dealt by our fuzzy sets. This is the difference between probability theory and fuzzy sets. That's what. Okay. So of course, when fuzzy sets were introduced, it was not appreciated by many people. It was not accepted. But the application part, you know, has been appreciated many. The fuzzy sets becomes renowned now because of its applications. The applications are data classification, decision analysis, expert system, time series prediction, robotics, and pattern recognition. So most of the Japanese people are using this fuzzy sets. Even if you look at the washing machine, the speed of the fan, AC controller, or or, or framed by the fuzzy logic concepts. Even the beauty of one of the applications of fuzzy sets in Japan, the 1000 series train is developed through fuzzy logic, through which they can control its speed. So this acts better than the human control acceleration. So that is a beauty, one of the beauty, this one and the washing machine are all one of the beautiful applications of fuzzy sets. This fuzzy sets dealt only the membership value of an element. It is not talking about the non-membership and ascendant part. To deal this, 1983, Antonosov has proposed intuitionistic fuzzy sets. This is a triplet. X is an element of a set. Mu of Ax is the membership function. V of A of X is the non-membership function. Okay. The membership function and non-membership functions values are taking from the set closed interval 0 to 1. From the closed interval 0 to 1. Okay. And it also satisfies a condition that membership, the sum of membership, non-membership value lies between 0 and 1. Okay. And here the hesitation part is there. Okay. The hesitation part phi of x is equal to 1 minus membership minus non-membership. So you can see here the intuitionistic fuzzy set is represented as 0.6, 0.1. This is a membership and non-membership of an element of x. So I'll give an example for this, how we can assign this value. Suppose we are suffering for a particular disease. So we consult with the doctor. The first doctor would advise us the chances of curability of this particular disease is 60%. Okay. And another doctor view is,
Excuse me, sir. So sorry to
yes,
interrupt.
yeah,
சார் ஆக்சுவலி அந்த எக்ஸாம்பிளில் லாஸ்ட் தெரியல சார். அது வந்து ஹைட் கொடுக்கணும்னு நினைக்கிறேன் சார்
சரிம்மா, ஓகே.
அந்த இதில்.
Yeah, 1 minute. Okay.
Yes.
Yeah, thank you. Now?
Yes, sir.
Yeah.
Now it's visible, sir. Thank you.
Yeah, okay, thank you. So here, the representation of intuitionistic fuzzy set is, here 0.6 is the first doctor opinion of the curability of the disease, and 0.1 is the non-curability of that particular disease by the second doctor view. Okay, this is first doctor view and the second doctor view on non-curability. If you sum this, 0.6 plus 0.1 is 0.7. The remaining 0.3, so 1 minus of 0.6 minus 0.1, this gives 0.3. That 0.3 is nothing but the hesitation part, indeterministic position, where they are not able to diagnose whether the curable or non-curable. Okay. Similarly for remaining two terms, so 0.8, 0.9, this point is the membership, 0.1 is the non-membership. Okay. Similarly, okay. And then, you know, in 1989, Antonosov introduced intuitionistic fuzzy sets of his second order with the property that the sum of the square of membership, non-membership less than or equal to n, when the situation membership, non-membership value greater than or equal to 1. So suppose the first doctor says the curability of the disease is 70%, therefore 0.7. The second doctor gives an opinion, the non-curability is 50%, therefore 0.5. 0.7 plus 0.5 takes the value 1.3. This is greater than 1. So when such situation occurs, we cannot deal with our intuitionistic fuzzy sets. Therefore, Antonosov proposed the second type intuitionistic fuzzy sets. Okay. So later, so many people were working on different types of fuzzy sets with different situation. One is the Pythagorean fuzzy sets, neutosophic fuzzy set, picture fuzzy set, spherical fuzzy sets, type 2 fuzzy set, soft set, rough set. These are the extension version of fuzzy sets. The interested people, you may work on it to explore more and more on the fuzzy sets. Since today we are dealing with the fuzzy sets, we will talk more on fuzzy sets. Okay, so this example, you quite often you might have heard from the expert. So one of the beautiful example that to understand the concepts, we can take the beautiful example that quite often said by the many people. So let me take A is the set of all tall people. So this is a fuzzy set. The moment I said the tall people, how would you come to conclusion that who are all tall? And if you are saying this, the person height, the 5.10 above are the tall people. So we are assigning membership is grade 1. People height more than 5.10 are given membership is 1. So if they are height less than 5.10 are given 0. Here my question is that the person height is 5.9. So the person height 5.9 who is very closer to the height of the person 5.10, and another person, this person, some 6.5, this person height is closer to 5.10. Okay, so the person height closer to 5.9 whose height is 5.9 is given a 0, whereas 5.10 is given membership is grade 1. Okay. And then the person height is 6.8 is also given 1. So what is the difference that we are showing? The 5.10 is also 1, 6.5 is also 1. So such question arises. Okay. So to deal this, fuzzy sets were introduced. Okay, look at this. You can give the value through our fuzzy sets. So look at this. If your height is 5.10, maybe his height with regard to with 0.5 membership grade, 6.2 with the membership grade is 0.10, and more than 7, maybe membership grade is 1. Okay. For every element, for every person's membership are given between 0 and 1, which are gradually increases. Okay. Which are gradually increasing. So with that, so we can go for easily good decision. So with that, the good decision can be made. So suppose I want to make a decision that all people, I would say the person I with a membership grade is 0.7, who may be taken as tall. So let me fix as 0.7. Okay. So 0.7, nothing but this people, something 6.2. The person height more than 6.2 are considered as the tall people. This way we can go for the decision. Okay. So the basic in fuzzy membership function. The first set is the after assigning membership grade, you will get the structure will be like this. This is the typical structure of the fuzzy membership function. The typical structure of the fuzzy membership function is the bell-shaped curve. After giving the membership function, membership value to a set, so we can talk about the support, core, alpha cut, height, crossover, normal, subnormal. The first one, support. Support is elements having non-zero degree of membership grade. The set of all elements whose membership grade greater than 0. So from here to this point, whose grade is more than 0. So therefore, this is called a support. This set of all elements are support. And core, the set of all elements having a degree is 1. Okay. Look at this. This set of elements takes the value 1. Therefore, this is called core. And alpha cut. This is through the alpha cut, we can take a decision. Okay. After assigning a membership value for elements of a set, we need to take a decision. So suppose you want to take a people whose grade is more than something alpha value you may fix as 0.5 or 0.7. So let me take 0.7 here. If you give alpha cut, the people who lie will be taken to the set. So alpha cut is really helpful to take a decision, okay, in the fuzzy sets. So alpha cut is defined the set of all elements whose degree greater than or equal to alpha. The height is defined as the maximum degree of membership. So here the maximum degree of membership, this is the maximum degree. This set of all people is getting the maximum degree. Therefore, this is called height. Okay, core in itself is a height. And then crossover. And elements having a degree is 0.5. So look at this, these 2 points. We obtain the membership grade is 0.5. Therefore, this is called crossover. And then normal. A set is normal if the height is 1. So look at this. The set is normal if the height is 1. Okay, this set we have the maximum, the membership grade is 1. Therefore, this is called a normal. And subnormal. Subnormal, a set is a subnormal if the height is less than 1. Okay, these are the preliminaries of fuzzy sets. Okay. The convexity of a fuzzy sets. So we know the convex set. Okay, take a 2 point in a set. Lines, draw line segments between these 2 points. The line segment completely lie in the set. That's a convex set. The convex set we can also define at the fuzzy sets. So the fuzzy set, the convex fuzzy set is defined like this. The mu of the membership of lambda x1 plus 1 minus lambda of x2. This grade greater than or equal to minimum of mu of a of x1 comma mu of a of x2. Okay. Where So look at this. Here I've taken, this is the fuzzy set. Here I've taken x1, x2. These are the two terms, two elements. Okay. The membership grade of x1 is 1. The membership grade of x2 is 1. And then this expression, lambda x1 plus 1 minus lambda x2. If we take this, okay, this may lie between x1 and x2. The membership grade is 1. So look at this. This set holds this condition. So the membership of this expression is 1. This is greater than minimum of, greater than or equal to minimum of mu of x1. This is also 1. This is also 1. So this is equal. So of course this condition satisfies. Therefore this is the convexity of a fuzzy set. And second one, this one, we take x1, x2. Okay. So here take this expression, it will lie between them. The membership grade is 0.4. 0.4 not greater than or equal to minimum of these two. Therefore, this is not a convex set. So similarly, we can define symmetry. A fuzzy set is a symmetry if mu of x minus c is equal to mu of a x plus c. Okay. So we can also talk about the open left, open right, and closed. So this is a open left. Okay, a fuzzy set is a open left if x tends to minus infinite, where the membership grade is 1. So when x tends to minus infinite, then the membership grade is 1. Okay. So whereas x tends to positive infinite, the membership grade is 0. This is open left. Similarly, we can define open right. When x tends to plus infinite, the membership grade is 1. Whereas x tends to minus infinite, the membership grade is 0. So if both minus infinite plus infinite tends to, sorry, x tends to minus infinite and plus infinite, the membership grade is 0. This is called closed fuzzy set. Okay, so this concept helpful for us to define left and right fuzzy sets. Okay, so we have various types of membership function. This is the one of the triangular and trapezoidal. These are the two membership function are predominantly used. So these two are a linear membership function. So the first one, the uncertainty arises at a point. Suppose my intention is to buy a t-shirt for 500 rupees. Okay. I cannot get exactly 500 rupees. It may vary some 400 to 600. If the cost goes, I may not be increases. If the cost increases, I may not be satisfied. But if the cost decreases, I may suspect that in the quality of the product, in the quality of the t-shirt or something. Okay. So if I get the t-shirt with a 500, I'm fully satisfied with the membership grade is 1. And if it increases, the membership grade will also gradually decreases. In terms of the cost, I may not be satisfied. If it is the cost decreases, I know that the particular t-shirt is really worth of 500. If the cost is decreases, I may suspect that there is a damage in the t-shirt. Okay, so if it is less than 400, the membership grade is 0, whereas greater than 600, the membership grade is 0. Okay, this is uncertainty at a point. Suppose I may fix, suppose if the t-shirt cost between 475 to 525, I'm fully satisfied. Okay, therefore I'm giving the membership grade is 1. Still, I may not get exactly between this interval. I may get 450 or 600 rupees. Okay. So here the uncertainty arises in the interval. Okay. So if you go like this, if less than 400, you may not satisfy in terms of the quality, goes more than 600, and we are not satisfied with the cost. So it will be in this form. So this is triangular. Triangular can be framed uncertainty at a point. Trapezoidal membership function framed uncertainty in the interval. Okay, these are the two fuzzy membership functions are predominantly used by the researchers. Okay, the membership function will be defined like this for the triangular membership functions. So look at this. It will be in the form of triangular. This is a triplet ABC. If x less than or equal to a, the membership grade will be 0. If x lies between a and b, the membership grade will be x minus a divided by b minus a. And then if x lies between b and c, so what is the slope of this particular point? We can determine through this formula, c minus x divided by c minus b. If c greater than x, the membership grade is 0. Okay. We can also define this triangular membership function through max-min operation. Okay. Through the max-min operation, maximum of minimum of this left-hand side spread, x minus a divided by b minus a, and then right-hand side spread, c minus x divided by c minus b, and 0, through which we can also determine the membership grade of an element. And then we can define for trapezoidal membership function like this. Okay. So if x lies between a and b, we can define like this, x minus a divided by b minus a. If x lies between b and c, the membership grade is 0, membership grade will be 1. And the right hand side spread, x lies between c and d, the membership grades are defined as d minus x divided by d minus c. Okay, so when x greater than d, the membership will be 0. Through max-min operation, we can define the same membership function like this. Okay, so these are the two linear membership functions are used by the researchers. So now let's move on to the non-linear membership function. So this is the Gaussian membership function, so which is defined as x comma c. C is the center, sigma is the variance, e power minus 1 by 2 x minus c divided by sigma square. Okay, sigma. So this Gaussian membership function, this is one of the non-linear membership functions. And another one, this is a bell-shaped membership function. This is the typical structure of the fuzzy membership function. So look at this. If the curve tends to linearity, then what will happen? We can get the trapezoidal. If this center portion, B and C are same, then what will happen? This becomes the triangular. So from the bell-shaped curve only, we can derive triangular and trapezoidal and all other membership functions. So this is defined like this. Okay, where C is the center and B is the slope. Okay. And then the fifth one, sigmoidal membership functions. So this is one of the most of the researchers were using at the neural network. This sigmoidal function acts as the activation function in the neural network. So when you stimulate a neuron, this neuron carries a message to another neuron through this activation function, through the sigmoidal function. Okay. So in order to mimic how human thinks, the human neural network can be converted into the artificial neural network. At the artificial neural network, they are using sigmoidal function as the activation function. This is defined as 1 upon 1 plus exponential of minus a into x minus c. Okay. Okay. So people are also exploring in other types of membership function. One is LR type of fuzzy membership function, S plus and S minus membership function, and other extension version of fuzzy membership functions are pentagonal, hexagonal, heptagonal, and it goes on. And intuitionistic fuzzy membership function is also there with the various. So whatever we had discussed, that was also applied at the intuitionistic fuzzy membership function. Researchers have worked on it. Okay. So then next we just move on to the fuzzy number and arithmetic operations. So everything is a matter of degree. What about fuzzy numbers? Can we fuzzy these up? Or fuzzy numbers are possible? The old answer was no. So how we could, how numbers could be fuzzy? So what about, so to answer this, what about the numbers closer to 0 or almost 0 or nearly 0? So look at this. If you take 0, 0 is my set, okay, because we are talking about the closer to 0. Here 0 is completely lie in the set. So what about this minus 0.001 here? 0.1. They are closer to 0, isn't it? So, and when you compare to -1 to -3, -1 is closer to 0 with a certain degree. So this information made us the triangular form. Okay, we can get this triangular form. This is what we had discussed now, triangular membership function. Okay, this is 0 fuzzy number. So fuzzy number is defined as, so fuzzy number is defined on the set of real number is said to be a fuzzy number if it satisfies the following conditions. Okay, and the membership function is the fuzzy set takes the maps from R2 close into 0, 1 as the following characteristic. The first one is the convex that we have seen. A tilde, the fuzzy set is a normal. Normal is the maximum membership grade is 1, and then this is a piecewise continuous. Okay, the triangular membership function we have seen. This arithmetic operation will helpful for us. Okay, so if A and B are two triangular fuzzy number, then the addition will be defined like this: A plus B is equal to A1 plus B1, A2 B2, A3 B C3. Sorry, this is supposed to be B3. Okay. Similarly, subtraction, multiplication, division we can define. So for subtraction A minus B, this is A1 minus B3, A2 minus B2, A3 minus B3. So multiplication, division can be defined like this. Okay. If A and B are two triangle fuzzy number, then the addition of these two to the above information. Okay. So from this, so we can observe the following things. So here, the addition and subtraction between fuzzy numbers become triangular trapezoidal fuzzy number. Look at this here. These two form, if you draw, it will be in the form of the triangular wave, triangular function, triangular membership function. Whereas the multiplication, okay. So from this, so we can observe the following things. So here, the addition and subtraction between fuzzy numbers become triangular trapezoidal fuzzy number. Look at this here. These two form, if you draw, it will be in the form of the triangular wave, triangular function, triangular membership function. Whereas the multiplication, division, and the inverse need not be the triangular trapezoidal fuzzy number. Okay. Even if you apply the maximum of a fuzzy number, is not always in the form of triangular trapezoidal fuzzy number. Okay. So to deal this, to bring the pictorial representation for fuzzy number, for multiplication and division, so we can bring other way of arithmetic operation. Okay, so if A and B are two fuzzy number, then addition and subtraction multiplication operation can be defined as follows through the weakest T norm condition. So this is addition between two fuzzy number under the weakest T norm. Similarly, the distance between them. So the addition is defined as A2 plus B2 minus maximum of left spread, comma, left spread of the first membership A tilde and the left spread of B tilde, and then mid portion A2 plus B2, and then A2 plus B2 plus maximum of the difference of the right spread of the A tilde and then right spread of B tilde. Similarly, the distance difference is also defined. Subtraction is defined like this. Okay. So if we take A and B are two triangle fuzzy number, the addition is defined like this through this. So here for the same fuzzy sets we have taken, we have through the weakest T norm we obtained 468. So for the previous one we obtained 369, whereas here we obtained 468. Of course we are closer to that. For the difference we obtained -2. The subtraction, I mean subtraction, we obtained -2 minus 1 0. For here we obtained -5 -2 and -1. They are almost same. For multiplication is defined like this. If A2, B2 are positive, these are the cases arises. For this, we define the arithmetic operation for multiplication of two fuzzy sets is defined like this. By using this operation, we obtain 4, 8, 12. For the previous set, we obtain 2, 8, 18. So this is also closer. For here, if you draw for a division, we obtain 0.6 and 0.5. It is not in the form of triangular. But if we apply the arithmetic operation using weakest norm for division, so division is defined like this, we obtain 0.25, 0.5, 0.75. This is in the form of triangular. Okay. So if you use the ordinary arithmetic operation for fuzzy number, we cannot get the triangular form. The resultant may not be the triangular form for multiplication and division. If you use the weakest norm, we can probably give the what is it, the output in the form of the triangular or trapezoidal form. Okay, so what we can do with the fuzzy number? So far we have learned the fuzzy sets, and then slowly we learn the fuzzy number. Okay, so what we can do with it? So with that we can reason them. Okay, so in practice, if you take any decision, anything, if you frame any rules, that will be in the form of if then rule. Suppose if the car goes too fast, then slow down. This linguistic term, fast, slow, can be represented the value by our fuzzy number. Okay. So fuzzy number helps us to give the value for the linguistic terms that we are using in our real life situation. Okay. In a real life situation, so when you do not have the enough information about any particular event, we will express in terms of the linguistic terms. Okay, do you like any particular movie? Do you like this lecture? So we may express in terms of superb, highly good, very high, and moderate. This value, this we can express. Such linguistic terms can be expressed in the form of linguistic value through the fuzzy numbers. So look at this. The no influence is defined as 0, 0, 0.25, whereas very low influence is defined as 0, 0.25, and 0.5. This fuzzy number helps us to provide the value for the linguistic terms. Okay. And even, so one can feel the cool with this temperature, 0, 0, 20, 25. If you draw, so one can feel the cool 0 to 20, one can feel extreme, the cool with the membership grade is 1. So, and then when you decreases, you may not feel cool. So at 23, you may cool with the degree of 0.4. Similarly, medium temperature will be in the 20 to 30, and hot is 25, 30 and above. 30 and above, the grade is 1 for a hot set. So this concept really helpful for us to frame a system. So that we are marching towards how we can frame a system. So these are the informations are really needed to frame a system. Okay, this is why I'm giving the basics and the preambles of the fuzzy sets. Okay, now it is our part. We have slowly move on to the fuzzy expert system. Okay. So the fuzzy expert system is a knowledge-based system. It can be framed by combining the knowledge of the experts. So the fuzzy cognitive map that was proposed by Casco in the year 1986, and then the same author proposed bidirectional associative memories, fuzzy associative memories, by combining fuzzy sets and the neural network. So these are the most of the researchers have used fuzzy cognitive maps, bidirectional associative maps, fuzzy associative maps. Okay. And then fuzzy inference system. This system was proposed by the Mamdani and Sujana. But here we are going to deal these two fuzzy inference system, Mamdani and Sujana. Fuzzy inference system works on the basis of if-then rule. This fuzzy inference system can also be designed either from the expert's knowledge or the available information, the data. So it has a lot of name: fuzzy rule-based system, fuzzy model, fuzzy associative memory, fuzzy logic controller, fuzzy system. Okay. So the fuzzy inference system that uses fuzzy set theory to map the input to outputs. Okay. So this is the flow chart of the fuzzy inference system. Whatever the situation you have, the situation will be converted or will be fuzzified. After specifying this, the expert will provide a rules for all the inputs. And the rules will be in the form of if then rule. If the first input with the degree this much and the second input of degree this much, then what is the output, the consequences. We are framing the rules. Okay. And then all the rules are combined. We obtain the distribution, fuzzy distribution function that will be defuzzified, and the defuzzified will be the crisp one. So whatever you're given, that the output should also be in the form of crisp. Therefore, we are forming a defuzzification. Okay. So here I'll tell you how the system will really work. So since we are going to talk about the medical diagnosis, so in our experience, we have been meeting a doctor whenever we are sick. So in our experience, who is the best doctor? So one may feel that whenever doctor asks question, if he says yes, then only doctor will give the good medicine. So we will say whatever he asks, he will say yes. So you would ask, do you feel headache? At the present situation, you may not feel headache. You might have had some yesterday. Then your intention is to say yes. If you say yes, then only doctor will give the good medicine. Then all your disease will be cured. Okay. So the good doctor is one who makes the patient to talk. Okay, the first doctor may not be the good doctor. The second doctor, one who makes you to talk. So if the doctor asks you what is your problem, then whatever we are suffering, that we will spell out. These are the problem, doctor, I have. I feel a continuous headache and fever, vomiting sense, and these are the things that whatever we spell out. With this experience, yes, come across many patients like this. So with this experience, he will give some medicine. Okay. So and then he advises take this medicine for 2 days and then come back. So if we are cured, then we won't usually we won't go and meet the doctor. If it is not cured, then what doctor will change the drugs. He will change the medicine. So doctor what is it, cures the disease in the form of trial and error. If continuously this problem has not been sorted out, what you will do. So doctor will ask us to go for the medical checkup. So you will ask us to take the our what is it, blood tests, some urine tests, and then other few tests he asked us to take. After that, and you would come to conclusion that you have this kind of fever, either typhoid with the low level or typhoid with the high level. This is the conclusion. He will come, he will take. Okay. So here for typhoid, he will go for some 5-parameter fever, and then what is it, the frequent thirsty, and then urine test. Some 5 tests he will go for it. After that, he will classify everything. Fever can be classified as very low fever, medium level fever, high level fever. Like this, we can classify. Similarly, our plate cell, okay, plate cell can also be classified low, medium, high. Depends upon the count. Okay, count of the what is a plate cell. You can classify low, medium, high, and similarly for urine also. So you will classify. After classifying this classification is nothing but the input are falsified. Okay. After falsifying the 5 inputs, and you will frame a rules. If what is that, fever is high, this is the first input, and you connecting this. The second input, what is a plate cell? Plate cell count is low, and the urine, the content, whatever the may be low, and then you may the age is also one of the parameter. So for youngster, the age can be classified as young, adolescent, old, like this. Okay. So you can also classify it. After falsified, he will combine. If age is old, then what kind of fever, the typhoid, what level. So this he can make a rule. So the doctor, the experienced doctor can make a rule. Okay. So because he had come across many patients like this, or also we have the database. Through the database also we can frame a rule. So we frame a rule. All the rules are framed, depends upon the input. And then after combining the what is that, rules, we get the output distribution. The output distribution is in the form of fuzzy set. So we cannot give the output in the form of fuzzy set. We need to convert into crisp. So the conversion from fuzzy to crisp is the defuzzifications. Okay. So here the two things are going to be discussed. One is how we can combine the inputs. The first here, how we are combining. Here I've used AND operations. So the connectiveness are really matter at the system. So in English we are using the connectiveness. What is that? Connectness and an OR in set theory also. Okay. These two AND OR operation, how we can define at the fuzzy sets. Okay. And then what are the methodology are there to defuzzify from fuzzy to crisp? So these are the two things are going to be discussed, and then we'll frame a system for some disease that we will find what it is. Okay, so the first one is the Mamdani method. Okay, it consists of 6 steps. The first one, we need to determine the rules. Okay, how many rules that we are going to determine for this particular problem, and then the fuzzifying the inputs as a how the doctor fuzzify the inputs, fever and everything. The fever, plate cell of a blood can be classified low, medium, high category. Like this, we need to fuzzify and provide the suitable membership function at step 2. And third one, combining the fuzzified input according to the fuzzy rules, so that we establish, okay, two rule strength. And at fourth, we need to give the consequence. If this is so, then what kind of the consequence will happen? So that we determine by our rules. Okay, the finding the consequence of the rule by combining the rule strength and the output membership function. And at step 5, by combining the consequence to get the output distribution. So we need to combine the consequence to get the output distribution. And finally, the output distribution is defuzzified. Okay. So look at this. This is the rule-based system. Here I've taken 2 input. One is a fever and another one is a plate cell. Okay. This is the first input. If the fever is low with the membership grade of this much, and the plate cell with the high, or this is also, yeah, low level with this grade. These two input are combined with the AND operation. AND is, what is the AND? AND is the minimum between them. So minimum between them, this portion. So therefore, the membership function will be in this form. Okay, this is for the second one. The plate cell, the fever is high with this much for the same patient. Okay, and then plate cell for I category this much. So minimum between them, this. Okay, so these two will be combined. This is the output distribution. Now this we need to defuzzify this. These are the two things are going to be discussed. How we can defuzzify the thing. How we can combine these two inputs. So we have AND, OR, negation. These are the 3 operations are there that we will see in detail. The first one is fuzzy connectiveness. A fuzzy connectiveness operator. The first one, AND operations. Okay, the fuzzy combination or T-norm and T-conorm that are going to be discussed. So look at this. This is 2 fuzzy sets. A and B are 2 fuzzy sets. Okay, A and B are 2 fuzzy sets. The intersection of these two is defined as T of mu of AX and mu of B of X. Mu of B of X. So this T is nothing but T-norm. This is defined by, in a different version, by the different author. The one is the minimum between them, the intersection portion. Okay, this is A and B. Okay, so let us see how this T-conorm is defined. So the triangular norm or T-norm is defined on the interval by satisfying the following conditions. The first one, it should satisfy the commutative, associativity, monotonicity, and neutral element rule. Okay, and then so the Zade has proposed the AND operation, the minimum between these two. So look at this here. The T is defined. The one of the operation is defined by Zade that the minimum between the membership of of an element of A and membership of an element of B. And another one is the product. We can also define T in terms of the product, multiplying these two. So both the techniques have the following two properties. Okay, look at this. In discrete mathematics that we have seen, the truth table A and B are two sets we have taken. Okay, these are the possible 0, 0, 1, 1 and 0, 1, 0, 1. Okay, so we have two sets we have taken. So 2 power n possibilities are there, the truthness of truth table. So here A intersection B is, what is that? The minimum between these two. 0, minimum of 0, 1 is 0, 1, 0 is 0, 1. So look at this. This satisfies this triangular norm condition. T of 0, 0, T of A 0, T of 0 A is 0, whereas T of A, 1 is equal to T of 1, A is equal to 1. This is the Boolean AND. We can also extend this Boolean AND into the fuzzy AND. So look at this. So A and B are classified like this, from 0 to 1, 0, 0 0.25, 0 0.5, 0 0.751. Similarly, A. Now, by the same operation, okay, we are finding this. So this will be the minimum between them, 0. So everything is going to be 0. So what about this portion? 0 0.5, 0 0.5. The minimum is 0 0.5. Okay, this one. This one is minimum is A membership grade 0.5. This is 0.75. The minimum between them is 0.5. So fuzzy AND operation also holds this condition. Holds this condition. And people were also exploring on AND with a different way. One is Lokovich's conjunction. This is maximum of mu of AX plus mu of B of X minus 1, 0, and immature conjunction. Next, we move on to the fuzzy R. This is T conum. So A and B are two sets. The union is defined as the maximum portion of these two. So T is defined T conum. Similarly, this takes a value between 0 and 1, which holds the following conditions: commutativity, associativity, monotonicity, and neutral element 0. Zadeh has also proposed the maximum between mu of A of X and mu of B of X, and the product so is defined mu of Ax plus mu of Bx minus mu of A into B of X. So this we have seen at the probability theory statistics. What is it? Sum of two events, additive theorem of two events. Okay, and this is also can also be called as inclusion exclusion principle. Look at this here. Actually, we are summing these two. So when you are summing A to B, this portion is counted twice. Therefore, here we are excluding one. Okay, the intersection part. So inclusion, exclusion. This is same as of inclusion and exclusion principle. Okay. Similarly, both the techniques holds the following conditions. So we can define Boolean R, and we can extend it into the fuzzy R. So between them, you can take the maximum. Okay. So if you want, so look at this, 0.5, 0.25. So maximum will be taken. So maximum of membership of A and membership of B. Okay. So Lukovich's disjunction, Immature disjunction, Einstein disjunction is also there. Okay. And negation, we know this, the complement of fuzzy sets. Negation for fuzzy sets. So A is 0.2 membership grade and 0.7. The negation of A will be 1.0.2. Similarly, this. Okay. So here we have seen the fuzzy set. You may have a question that whether the fuzzy set holds all the condition of classical set. No. So fuzzy set doesn't hold good the law of excluded middle and law of contradiction. So this one, at crisp set A union A bar is equal to X, whereas the fuzzy set A union A bar not equal to X. Okay. So look at this. This is A of X, and the complement is defined like this. So A union A bar then maximum between them is taken. Okay, the whole thing not equal to x. Similarly, law of contradiction. A intersection A bar is equal to empty at crisp set. At fuzzy, A intersection A bar non-empty. Okay, the same set we have taken. Intersection, the minimum between them will be taken. But in a crisp set, everything will be 0. Whereas what we obtain, x2 is 0.3, x3 is 0.4, x4 is 0.5. So therefore, this is not empty. It contradicts the law of contradiction. So we can also talk about the Cartesian product of two fuzzy sets. Cartesian product of these two fuzzy sets. A of x is defined in x, b of y defined in y. The Cartesian product of a of x into b of y is defined like this. The minimum of the membership of a and b will be taken. Okay. So let us see an example. A and b are two fuzzy sets. The Cartesian product of x1 and y1. First, let us take the minimum between them will be taken 0.2. Similarly, x1, y2. So 0.2, 0.6. The minimum is 0.2. Similarly, you can frame and you can obtain this matrix. Cartesian product of the two fuzzy sets. So we can also define the maximum of composition. So A and B two fuzzy sets, fuzzy matrix. Okay. So the maximum composition is defined as the maximum of minimum of Aij, Bjk. So Aij is the A matrix, Bjk is the Bth matrix. Okay, the resultant will be the C. So let us see an example. To an example, A and B are two matrices. Okay. The maximum composition. Let us take this row and this column. So you can compare 0.2, 0.3, in which the minimum will be taken. 0.3, 0.1. Minimum need to be taken. Among them, we need to go for the maximum. So the maximum is 0.2. Similarly, for all the entries. So for this row and this column, 0.5, 0.3, 0.3 is minimum, 0.7, 0.1, 0.1 is the minimum. Between them, 0.3 is the maximum. So we can obtain. So this is one of the beauty of fuzzy sets, fuzzy extension principle. Okay, so this is one of the good contribution from Zade. So look at this, x and y are the mapping is defined from x to y. Okay. So A is the fuzzy set of your x, B is the fuzzy set of your y. So when the membership of the mapping will be given, the membership degree of an A will be given, and we need to find out what would be the grade for your B through this fuzzy extension principle. So the membership of B of y is defined as the maximum of the set of all elements in a gamma inverse of y. Among them, the maximum will be taken, provided that the gamma inverse of y is non-empty. If this is empty, this will be 0. So look at this. This is the example. Through the example, we can understand that A is our fuzzy set, is a subset of your x. Okay. And then the mapping is also given. The mapping gamma of x1 to y2, gamma of x2 to y1, y4. This gamma need not be the single value function. Gamma of x3 goes to y1, gamma of x4 goes to y3. Similarly, the mapping is given. Okay. So here we need to find out what would be the membership grade for our B. So B is the subset of your y. So here we need to find out the inverse mapping. Okay. So we need to find out the inverse of y. So look at this. So inverse of y1, where the y1 is. So inverse of y1 here, x2, and then x3, inverse of y1, x5. Similarly, for remaining term, we determine. Okay. So inverse of the first one, let's find out mu of b of y1, mu of b of y1. So the inverse of y1 is, what is that, x2, x3, x5, x2, x3, x5, whose membership grade is x3 is 1, x5 is 0.2. The maximum is 1. Similarly, for remaining element, let me tell you for y4. So y4, the inverse of y4 is x2, x3, x7. So x2, x7. So x2 membership grade is 0.7 and x7 is 0.8. So among them, the maximum is 0.8. Therefore, the subset B of Y, whose membership grade is y1 is 1, y2 is 0.9, y4 is 0.8. The people who want to know about many things about is, the fuzzy sets and the extension principle, please, you may refer this paper. So this author Carey was share his experience on fuzzy sets and extension principle where we can really apply. This extension principle we can use very well in the medical diagnosis. Please, if you look at this paper, he would be talking about the medical diagnosis aspects, and he also shared his experience how he enjoyed with the fuzzy sets and extension principle when he compared to other concepts that he has learned. Okay. So now, you know how to create a fuzzy rules. So far, what we've done, so we learned about the connectiveness. Okay, connectiveness. Still, we have not done what is it? Defuzzifications. After doing this, we will go for the constructing model for medical diagnosis. Okay. So rules can be defined through if-then form. If temperature is high and humidity is high, then room is hot. Okay. So here temperature and humidity are the input. Okay. This is the grade of humidity, and room is hot. This is the consequence. Okay. So fuzzification, how we can fuzzify that I said. The temperature, I mean fever can be classified low, high, medium, high. Similarly, you can classify large or small, old or young, hot or cold, etc. We can fuzzify the things. The consequence of a fuzzy rule is computed using two steps. The first one, computing the rule strength by combining the fuzzified inputs using the combinations. So these are the connectiveness. Using these two connectiveness, we can compute the rule strength. So and is the and or operation. Okay. So and then the clipping output membership function at the rule strength. Okay. So this is what we have seen, and operation that we have seen, connecting these two input. Okay. If you consider what is it, the temperature, this is humidity. These two are connected with the AND operations. Okay. Now let's move on to how we can defuzzified this output distributions. Okay. These two input are combined with this output distribution. Now let's learn how to defuzzify this output distribution. Okay. So far there are so many methods are there for defuzzification. So one of the method is center of sums method, center of gravity, weighted average method, the maxima method, first of maxima method, last of maxima method, mean of maxima method. So these are the methods are there. As I said, defuzzification is the process of converting the fuzzy set into the crisp one. Okay. So first, I'll tell you one or two steps here, one or two types, center of sums and weighted average method. Okay, the first one, center of sum method. So this is defined as x bar sum of ai xi bar divided by sum of ai, where ai is nothing but the firing area of the ith rules, and k is the total number of rules fired, and xi bar represents the center of an area, So look at this, consider this is the output we obtain. So output distribution, this is the output distribution. So here A1 is represents the firing strength of the first rule, and A2 represents the firing strength of the second rule. Okay. So here 2 is the total number of rules. 2 rules are fired. If 10 rules are fired, you can have the 10 fuzzy sets here. Okay. Now we are going to defuzzify this to provide the crisp in output. Okay. So this is what we are given. Okay. So we know how to find the area of trapezoid. So 1 by 2 h into a plus b. Okay, so first let us find out this a1. Okay, so a1 is equal to 1 by 2. Okay, the width 8 minus 1 plus 7 minus 3, the perpendicular distance between them, 7 minus 3, into height. What is the height? Height is 0.5. Okay, so we can obtain 2.75. Similarly for a2. So 1 by 2, okay, the length of the width 9 minus 3 plus the perpendicular distance between them. What is that? 8 minus 4. Height is 0.3. This is what we obtain. And then here we can also find out the area of a1, a2 we have determined, and we need to find out the midterm x1 bar, the average. The x1 bar is so 7 plus 3 by 2. And similarly, the x2 bar of C2 is 7 plus 8 plus 4. And then we can substitute in this formula, we obtain 5.35. Okay. So what is that? This output distribution, the fuzzified one, converted into crisp form using the center of sum method. Okay. So through which we can come to conclusion. Okay. So one is the center of gravity method. Okay. So here the area is being divided into small sub areas, and then we calculated the areas. So 1, 2, 3, 4, the same what is that output distribution we have taken, and or divided into small segments. Okay, and then we find the area of it and substitute here, we obtain the results. By doing that, we obtain 5.008. For the previous one, we obtained 5.35. Okay, so almost we are also closer to center of sum method. Okay, and third one, the weighted average method. Okay, the weighted average method is defined like this: sum of u of x, mu of x divided by sum of mu of x. Okay. So this method is valid only when the fuzzy set is symmetrical one. Okay. So this results are very closer to the COA method. Okay, center of average method. This method requires less computationally intensive. Here, each membership function is weighted by its maximum membership value. So let us take this example. Okay, consider this is the performance of a particular subject in a class. 60% people have passed with the membership grade is 0.6, and then what is it? 0.4 grade of people who got fair degree, and good scored 0.2, very good 0.2, excellent is 0. So whose distribution, the output distribution is given. Okay. So here it is said that the maximum membership grade will be taken into an account. So 60, the maximum membership grade is 60, therefore 60 and 0.6. 60 scored 0.6, and then 70 whose membership grade is 0.4. The maximum membership grade of a function will be taken, and then here 80 into 0.2, and then 90, 0.2, 100 is 0, and here we obtain the average is 70. Similarly, the maximum method, there are three types are there: first of maximum method, last of maximum method, mean of maximum method. Okay. In the first of maximum method, the smallest element gets the maximum membership grade. The smallest element among them, 4, which gets the maximum membership grade 0.2. Therefore, the first of maximum method is 4, and then the greatest element gets the maximum membership grade. The greatest element gets the maximum membership grade is 8. Therefore, last of maximum method is 8. If more than one element gets a maximum membership grade, take the average. That is the maximum, mean of maximum method. So there are so many defalsification methods are there. If you ask which one is the best or better, we cannot say this. Depends upon the situation. We can bring the defalsified method. You can work on it. Okay. Okay. Another one is Sujano method. We have seen that at the Mamdani method, if x is the output is a linguistic term, y is also linguistic term fuzzy, then the consequence will also in the form of fuzzy. Whereas the Sujona is the output will be in the form of function of the input. This is the only difference. Okay, so output will be in the form of function of your input and output. Whereas at the Mamdani method, the output will also in the form of fuzzy. Okay. If the function is a first order polynomial, then the resulting fuzzy inference is called first order Sujana fuzzy model. Okay. If the function is constant, then it is a zero order Sujana fuzzy model. Okay. So here the overall output is obtained through the weighted method. Okay. Here each rule has the crisp output. Okay. So the difference between Sujana and the Mamdani is only the output. Here the output will be in terms of the function. At Mamdani, the output also will in the form of fuzzy. Okay. So if you want, you can look at it. So this is the first input, this is second input are combined through AND operations. The output will be in the form of x1 p1 t plus q1 p. T and p are the functions. Okay. So plus r1. Okay. So p1, q1, r1 are user defined. Okay. And then these two rules are combined. This is the resulting action. So if you want to fix some examples for the Sujana method, if x is small, then this is the output. Only one input is taken here. X is medium, then y is this. If x is large, then y is equal to x minus 2. Okay, if you plot through MATLAB, the overall membership, the overall output will be in this form. If we take the same in terms of the fuzzy, the output will be like this. So now, so far we have learned about fuzzy sets, and then fuzzy number, the arithmetic operation, and then Mamdani method, Sujana method, in which the connectiveness and R operation and the defuzzifications are really matter. So we have learned the system. Okay, so to make a system, what are the things are required that we have seen. So now we are going to diagnose type 2 diabetes mellitus through the fuzzy inference system. We know this. The type 2 diabetes mellitus is one of the alarming diseases in both the developed and developing countries. So in India, most of the people are living without ever that they are affected with the type 2 diabetes. So that is one of the sad thing. And the undiagnosed type 2 diabetes leads to many complications, especially in eye, heart, kidney, all the nerves. Okay. So it is better to diagnose early. So it is advised a person age is more than 38 or near 40, they are advised to check up their health. Okay. So here we are interested to frame a fuzzy inference system to diagnose this type 2 diabetes mellitus. In rural areas, mostly doctors, the experts are not easily available. At this situation, what we can do? So we can frame a system. So this system mimics the expert doctor, how the expert doctor acts. We can bring in terms of the artificial form. Okay. So here, the system has 5 steps. The first one, we need to frame a n input factors and m output. Okay. So n output, n input may be for maybe whatever doctor would take that input, and output the health condition. And we at step 2 we divide all the input factor and the output into linguistic terms. We can classify into linguistic terms, and we provide the suitable membership function for this at step 3. And at step 4 we can frame fuzzy rules. Okay, we can frame hidden rules with the help of the medical experts. At step 1 we frame a fuzzy strings. The first input level this much, and second input this much. Similarly, 5 inputs, and the fifth input this much. We frame a string, and then at step 2 we find the calculating firing strength. So we will calculate the firing strength of the input. Okay, and at step 3 we will find the consequence of it. So if this is so, then what will be the consequence? So finally the outputs is defuzzified through any defuzzification method, the centroid method, average method, any method, through the any method. So we have learned the method. So here we have learned defuzzification method. So this connectiveness operation are also learned. So the final output would be the required diagnosis. So this is how we can frame a fuzzy rule system. So here I have taken for diagnosing type 2 diabetes. So age is the matter. Age, high density lipoprotein, low density lipoprotein, body weight, physical activity. These are the 5 input are taken, okay, for framing a system. Okay, so we cannot confine into the 5 input. We can also bring the more input which is really required, and one output variable is chosen. This is health condition. Okay, and then at step 2 we classify all the input into the linguistic term, and at step 3 we provide the suitable membership function. So look at this here. The age is classified into adolescent, young, middle, old, very low, old. If the age is less than 20 is adolescent, 15 to 35 young, 30 to 50 middle, 46 to 65 old, greater than 65 very old. And we also provide the suitable membership function for this. So adolescent, if x less than or equal to 15, the membership grade is 1 with the adolescent set. Lies between 15 to 20, the membership grade 20 minus x divided by 5. If it is more than 20, whose grade is 0. We may not be in the adolescent set. Similarly for young, middle, old, everything. Suppose, so 32 is taken. So 32 lies between here, 35 minus 32, so 2 by 5. Okay. So whereas here also, yeah. So here the membership grade 32 minus, this is also, yeah, this is 2 by 5, whereas here we obtain 3 by 5. Okay. So here the membership grade is 0.6, whereas here we obtain a membership grade 0.4. A person whose age is 32, he comes to under young category with the membership grade is 0.6, whereas at the middle category with the membership grade 0.4. Okay. Similarly, we will we will classify high density lipoprotein, low density lipoprotein, body weight index, physical activity. We classified and provide the suitable membership function. Look at this, the classification for high density lipoprotein, low, medium, high. Similarly for low density lipoprotein, and the pictorial representation for the classifications. Body weight, and then physical activity. The output is the health condition is classified into 7 linguistic terms: very low, low, medium, high, severe, and very severe. Okay, so here 1200 rules are developed with the help of the medical experts, Dr. Sebastiana and Dr. Morgan. So with the help of them, 1200 rules are framed like this. So look at this, the rules. So age is adolescent, high density lipoprotein low, low density lipoprotein optimal, body weight underweight, physical activity low effective, then the chance of type 2 diabetes is very low. Similarly, we define for 1200. Okay. And then all the informations are incorporated in the MATLAB. We frame a system. Finally, you obtain this kind of rule-based system. So look at this. This is the scale where you can move here and there. So let me keep this with the age is 40. High density lipoprotein is 45. Low density lipoprotein 135. Body weight is 30.5. Physical activity is 60. And so here 1200 rules are taken. So you may have the output distribution in the form of 1200, and that classified, and we obtain a health condition 0.7. If this is the situation, he has a chance of getting the type 2 diabetes with the 0.7 level. Okay. This is the surface viewer of the input. Okay, this is the situation we have taken. Consider one of the patient whose age is 40, high density lipoprotein 45, low density lipoprotein 135, or the body weight, body mass index 30.5, and then physical activity 60 minutes per hour. Okay, this is so. Then this 40 completely lie in the middle age group. Okay, the membership grade is 1. High density lipoprotein, medium with the membership grade is 1. And then high density lipoprotein. This is in the borderline with the one membership grade. And then body mass index, obesity with the membership grade is 1. And then physical activity, enormously effective. So this is these inputs are combined. Okay. So this is by either through AND or operation, and we obtain from the uh, system the type 2 diabetes for that particular patient. He has a chance of getting type 2 diabetes with a severe level. So through which, we can help the patient in diagnosis the disease, and we can also detect the disease so early when the medical experts are not easily available, especially in the rural areas. Okay. So nowadays, we are facing the situation COVID-19. So the COVID-19 forced us to go for this online mode. You know, you know. Yesterday I had a word with one of the professor. He said that the people who are able to adopt the situation, they are able to survive. So we need to adopt this kind of situations. So this is, though it is a new, we need to adapt into the situations. Still it is uncertain of determining the symptoms of COVID-19. Every day we are getting new symptoms of COVID-19. So by yesterday I received this is the most common symptoms and less common symptoms and serious symptoms. So most common symptoms are fever, dry cough, tiredness. So among them, what is the predominant symptoms that you can choose? And then you can also classify into the linguistic term and provide the membership function, and you can frame the same fuzzy inference system so that we can help uh, the people to diagnose whether they are affected with the COVID-19 or not. So, recently we have also got the mail from the Apollo that they are making an artificial intelligence system. They will ask our age and fever, whether we have a continuous fever or dry cough, tiredness. They will ask the question, we need to give the response, and later whether we have COVID or not. So that they have framed. Similarly, by using the fuzzy sets, we can also do the inference system to COVID-19. The people who are really interested, you can frame a system, inference system. So here we can also incorporate the neural network concept as well. So by combining fuzzy sets and neural network, which acts better, so which mimics how the human thinks. So that's what Bartkas also said. Fuzzy logic and neural network are two sides of the same coin. So these are the two, predominant area people are working in diagnosing the thing. Okay. The current trends, the people who are interested, we can also work at the fuzzy optimization, fuzzy clustering, fuzzy implication, artificial fuzzy neural network, application of fuzzy logic in computer networking, data mining, knowledge management, inference system with other extended version of fuzzy sets. So I told you that what are the extended version of fuzzy sets. So if you need to explore, you can do that. And we can also make a decision analysis. Here you may ask, so what are the input that we can take for COVID-19? So still it is not certain. So here, we can also go with the decision making models that the predominant symptoms can be taken through the available method, the fuzzy decision making models, DMATL, TOPSIS, PICAR. These are the methods are there. This helps us to uh, rank the attributes. Okay. So, so these are the reference that I've taken for my talk. Is it tasty? Let me leave it to you. Thank you. So again, let me thank the organizer for providing this wonderful opportunity to meet you all. Thanks a lot.
Thank you, Dr. Felix. We thank you for the informative talk that you have delivered to our audience this afternoon. I also thank all the virtual audience for actively participating in this national webinar. Now, we will move for discussion. Anyone to clarify anything can do so. Dr. Felix and other teachers and all the delegates are once again invited to join for the discussion live in Zoom. For joining in Zoom, those who are viewing on systems, on the same screen to your right, there is a discussion live by Zoom. Kindly click that tab and you will be taken to the Zoom. And those who are viewing on mobiles, slightly scroll down, you will find the same tab, discussion live by Zoom. You may kindly click it, you will be taken to Zoom. By any reason, due to settings on your respective systems, if it asks for password, kindly type 12345. I repeat, if it asks for password to enter into the discussion, type 12345. We look forward to see you all in Zoom now, and the speaker session is completed now. Now we will move for discussion. Thank you.